Hello viewers, in this video we are going to look at the different types of sparse arrays using SciPy implementation. Subscribe to my channel to get alerts on more videos from my channel. So when it comes to computers, we work with a lot of data structures. So one such data structure is array, which is going to hold a collection of items. You can check my videos to understand how to work with arrays using Python libraries. And in this video, we are going to focus only on sparse arrays. Sparse arrays are a special kind of arrays where only a few locations in the array will have data, which is actually exactly opposite to the dense array. And in sparse array, if there is no data, then it will be indicated as 0. In SciPy, we have 7 different types of sparse arrays. They are the coordinate format, the compressed sparse row format, the compressed sparse column format, block sparse row, list of lists, dictionary of keys, and the diagonal format. We are going to look at each of them in detail. So to start with the sparse array, let's start with a very simple array, which is the coordinate format. In this example, we have the NumPy array, which is ARR1. We can see that there are only 5 non-zero values in this NumPy array, which are 1, 2, 4, 1 and 5. So what this coordinate format does is, it stores the coordinates of the non-zero values in the array along with the values. I am giving sparse equal to sp.sparse.coo_array because we are going to call the coordinate array. And we are passing ARR1 to this coordinate array. So this is ARR1, which is our input array, and this is the coordinate array. So you can see that the first non-zero value is 1. So this coordinate is 0, 0. So we have 0, 0 to be 1. Next we have the value 2 in the position of 0, 3. So we have 0, 3 and the value to be 2. Similarly, 4 is in the position of 1, 1. So 1, 1 and the value 4. And this is how the coordinate array gets generated. This format is also called the triplet format because it records 3 entries of an array, which are the row number, column number and the data. On this sparse array format, we can apply a variety of methods, which are the min, max, which is actually going to fetch us the minimum and the maximum value from that array. Call is going to return us the coordinates 0, 3, 1, 2, 2. And row is going to return the row coordinates. By using sparse.nnz, we can actually fetch the number of values that are present in the sparse array. And to get the sum, we can use the sum method. One drawback in this array is that it cannot be subscripted or sliced, meaning I cannot fetch the portion of the sparse array value by providing the coordinates. It simply throws an error that this array object is not subscriptable. The next array that we are going to look at is the compressed sparse row format, which is the CSR array or the CSR format. And this type of array is going to be very useful when it comes to vector products and row slicing. So in addition to building an array from NumPy ND arrays, we can also build arrays using the row, column and the data values. Using these values, we can build a sparse array. So we can give sparse.csr array of data, row, column, and this is how we create the CSR array. And we can see that the CSR array got created based on the values that we have provided in row, column and the data. That is, row 0, column 0, we have the value to be 1, and these are the coordinates for which the value is 1. And for the coordinates 0, 3 it is 2, for 0, 3 it is 2, and this is how we can build the data. In the same code snippet, I've made a minor modification where I have given 0 as one of the values in the data array. One thing to note here is that if we explicitly specify the value as 0, then CSR array will consider it to be a value, and then it is going to store that value in that coordinate. So this value, which is 0, will not get ignored if we explicitly specify it. But if we convert this array to a dense array, then we'll not be able to see any difference between the missing value and this data, which is 0. So this is one area that need to be taken care while providing 0 as one of the data values. And another thing to note here is that since we are explicitly specifying the value of row, column and data, we might miss on the uniqueness of the coordinates. In this example, I have repeated the coordinates 1, 1 twice. In the first set, the value is 4, whereas in the second set, the value is 1. When I create a CSR array based on these row, column and data, I'll notice that I get only 5 values, because what happens is for 1, 1 coordinate, the value gets summed up, which is 4 plus 1 will now become 5, which will be available in the 1, 1 coordinate. The third type of array that we are going to look at is the compressed sparse column format. When it comes to the result, both CSC and CSR are going to be the same, but just that in CSR, the compression will be based on the row, whereas in CSC, the compression will be based on the columns. So in the CSC array, values are read column by column, with each value containing the row index and the column pointer, whereas in CSR, values are read row by row. It all depends on how you want to slice the data that matters to choose between CSC and CSR. BSR, which is the block sparse row format, is very similar to CSR. The compressed sparse row format, BSR will be appropriate for sparse arrays with dense subarrays. If you consider this example, we have a dense subarray for which BSR array will be more efficient when compared to the CSR format. LIL array, which is list of list format, is yet another sparse array with the row based array. So in this example, we have given a 2D array as an input to the LIL array, which is again based on rows. The next type of array that we have is the dictionary of keys based sparse array. This is an example where we are creating values based on dictionary of keys. Furthermore, this is an efficient way of creating sparse arrays incrementally. So first we are creating an array of 5, 5, and then we are incrementally updating the values of each of these coordinates based on the for loop. The next most interesting type of sparse array is the diagonal format. The way it works is, the rows of an array will have an offset value of 0, -1, -2, -3 and so on, whereas the columns will have an offset value of 0, 1, 2, 3 and so on. So the offset value that we provide in this array will indicate from which row or column the values should be diagonally populated. So I have the data object here, which is going to hold 1, 2, 3, 4, 5, 6, 7, 8 and 8, 9, 0, 0. And then I have defined the offsets here, which is 3, 1 and 0. So when I call the diagonal array by passing the data and the offsets by giving the shape as 4, 4, so what exactly happens is, so we have the data here. So this data will be considered for the diagonal format, and we have given the offset here. The first offset value is 3. So this array is going to be diagonally populated. So the column pointer is going to be 0, 1, 2 and 3. So from here it's going to be diagonally populated. But since we have only one value in that diagonal, so from the last 4 will be considered. The next offset value that we have is 1. So 5, 6, 7 and 0 is going to be diagonally populated from 1. From 1 we can populate only 1, 2, 3 values. So the last 3 values will be considered, which is 6, 7 and 0, and 6, 7, 0 gets diagonally populated. 8, 9, 0, 0 is going to be populated from 0. So from 0 we have 8, 9, 0, 0 to be populated. Say for example, I want the values to be diagonally populated from the rows. Then I can give 3, -1, 0. If I execute this code, we can see that 5, 6, 7, 0 is going to be populated from the second row. and this is how the diagonal format works. To summarize, for efficient array creation, the doc array or the LIL array is highly recommended. The LIL array class supports basic slicing and indexing, and the syntax is almost going to be the same as that of the NumPy arrays. The methods might be similar to NumPy arrays, but it is strongly recommended not to use NumPy functions directly on these arrays because the NumPy may not properly convert them for various computations. So the result might be incorrect. For any implementation, first check if SciPy has its own implementation for sparse array classes. If you still want to proceed with NumPy function on these arrays, then convert the sparse array to a NumPy array by using the toArray method and then apply the NumPy method. Hope you have got a clear picture of the different types of sparse arrays available in SciPy.